Hey guys, in this video we're going to be doing Target 2 8.3. Our mastery learning objective is I can identify the domain and range of a parabola. Now if you could get two different colors, markers, whatever, I'm sure your teachers have some laying around. You're going to need two different colors for this activity only because it's going to help things make a little bit more sense. So the first color is domain. Domain is all the possible x values. Alright, what I want you to think then of domain is how far left and right the graph goes. So anytime I'm asking you about domain, that's the question I want you to ask yourself. How far left and how far right does the graph go? Because that is all the possible x values. Now with your other color, range is talking about the other values that we have in a graph, which is the y values. So range is going to be all the possible y values. And the question I want you to ask yourself here is, well, how far down and up the graph goes. Now again, it's not what like the tally marks on the graph, it's what the actual function is doing. Alright? So looking at example 1, it says how far to the left does the graph go, and how far to the right does the graph go? Well, if I'm answering this question, looking at our function here, how far left does the graph go? Well, my graph here keeps going up forever, right? Well, then my x-axis also has to keep going on forever, right? And the value that we use when it keeps going on forever is negative infinity, right? There is a negative sign here. So how far does the graph go? Well, it goes left forever. How far right does it go? Well, I see that this function is keep going up forever, which means that x-axis is also going to keep going to the right forever, and the value that we use there is a positive infinity. So it goes right forever. So then if I ask you, well, to identify the domain, we kind of already did it. If we say it goes left forever, we're going to use a negative infinity sign. If we say it's going to go right forever, then we're going to use a positive infinity sign. Put that in parentheses because we're going to use our notation for domain. So negative infinity to positive infinity. The next step is saying, well, what is the vertex of our parabola? Now, thinking back to our vertex from last video, it is either the highest point or the lowest point. So in this case, we have a minimum because we have this lowest point right here, which is at a negative 1, 0. Right, this right here is our lowest point. So if you want to think about it, this is a minimum. Alright, now from that vertex point, does the graph go up or down from there? Well, if this is my vertex, I'm going up, right? So that's going to be all these y values going up forever. So it's going up, which means we'll identify the range. Well, our lowest point then is the point that I have to use. Our lowest point was 0. And then it's going up forever, which means up forever is a positive infinity for y. Right? This is a positive infinity. This is a negative infinity. Values of y, right? Going up forever. Now, the other thing to keep in mind is that once you identify that vertex point, that y value is the same y value that you are going to be using in the range, right? So in our range here, I want you to kind of highlight that whatever y value you have is the same y value you're using in the range, right? Because that is your lowest or your highest y value, and then from there you decide if you are going up or down. All right, let's try to look at another example here. Example number 2. It says, how far left does the graph go and how far right does the graph go? Well, how far left, I see that my parabola is going downward. I see those arrows, which means that's going to keep going down forever. So I have to accommodate those x values. So that's going to keep going until negative infinity. So it goes left forever. And how far right? Well, also I see my parabola going downward, which means my x-axis is going to keep going on forever in this direction as well. So that is going left and right forever. And right. So again, we'll identify the domain. Well, if it's going left forever, we know that's going to be a negative infinity. If it's going right forever, we know it's going to be a positive infinity. Next is, we'll identify our parabola, our vertex of our parabola, so that we can identify what our range is. So our parabola here is at either that highest or lowest point. I do have that highest point right here, which is a 2, 3. Right, that's the highest point. Right, nothing is past that, which means this is a maximum. Now from that vertex, does my graph go upward or down? And it does. From that vertex point, it goes down. So all these y values down in the negative direction until we get to negative infinity are included on my graph. So it does go down. Now again, I'm going to use that y value, right? Our y value was at 3. So everything from 3 down to negative infinity for my y are included in my range. And again, if you need to highlight that for yourself, because of the fact that our parabola, that vertex, this is the highest point, there is not going to be any other y's higher than that point. So you always start from that y value and then tell me if it goes up or it goes down. All right, go ahead and flip it over to the next example. So now we're going to try to incorporate everything that we've talked about so far. First thing says, well, identify the x-intercept. So where does my graph cross the x-intercept? The x-axis. I see an x-intercept right here, and I see an x-intercept right here. Which means then that x is going to equal roughly about a negative 2.5. And x is also going to equal about a positive 0.5. Again, that's wherever the x, our function touches that x-axis. Identify our vertex point. So again, this is either a maximum or a minimum. We do see that we have a parabola facing downward. So that means our vertex then is a highest point, which is a negative 1, 3. All right, this is a maximum. Identify the domain. Well, my function here keeps going from my vertex. He's going to keep going in this direction to negative infinity because my function keeps going. It doesn't stop, right? These arrows right here tells me it's going to keep going down. It's going to keep going down. So therefore, my x-axis also has to go to the left forever as well as to the right forever to positive infinity. So my domain then is going to be negative infinity to positive infinity. Hopefully you're seeing a pattern because for all quadratics, for all parabolas, the domain is always going to be negative infinity to positive infinity. It's just something that we see with parabolas because they keep going on forever. looking at my range now, I have to start at that y value. That y value, right, we said was at 3. Now I look at what my parabola is doing. At that y value, my function is going down forever until negative infinity, right? It keeps going down. So my range then, we can say is going from negative infinity to 3. Alright, the next couple of examples, you are going to use your calculator. We are going to graph some of these. So if you do not have it already, please press pause and grab your calculator. Alright, so looking at example number 5, we have f of x equals x squared plus 4x plus 3. So going back to our calculator, we want to make sure that we start a new graph. So new document, no, we never want to save. This can get minimized. We want to add a graph. And I'm going to go ahead and type in that function. So x to the second power plus 4x plus 4x plus 3. So I got my function here, and I want to find my vertex point and my x-intercepts. My x-intercepts are actually nice to count. I see I have one right here at -1, and I have another x-intercept right there at x equals -3. If you want to go ahead and do that, scroll left, scroll right, you can. But when it's easy to count, you can just go ahead and count our x-intercepts, which is x equals -1 and x equals -3. So x equals -1 and x equals -3. Those are my x-intercepts. I'm going to go ahead and plot that on my graph. So x equals -1, x equals -3. Please make sure yours actually look like that. So for some reason my board is actually not so good. Identify the vertex. So I see my graph. I have a lowest point, right? We have a minimum. So I'm going to go to menu, down to analyze graph, and I want to find a minimum. I want to scroll just left of that lowest point, scroll to the right. Once I pass that lowest point, my vertex point does come up, and it says it is a -2, -1. So I'm going to write that point for my vertex, -2, -1. So -2, -1. I'm going to go ahead and graph that point. Okay. My domain. Well, the domain went all the way to the left, right? And then we have all the way to the left, all the way to the right. So my graph here, remember that my domain is the x-axis. So everything left to positive infinity, to negative infinity, and all the way right to positive infinity. So therefore, my domain is -infinity, infinity. My range, I have to use that point of my vertex, which is -1. From that point at -1, my graph is going upward, right? From that y equals -1, my graph is going completely upward. So therefore, I'm going to write comma upward positive infinity. Right? Because positive infinity is up here, negative infinity is down there. Alright? Looking at example number 6. Well, right off the bat, I see that I have this negative sign in front of that x squared term. So I do know it's going to be a parabola opening downward, which means I have a maximum point. So we want to start a new document. No, we don't want to save. I want to add a graph, and I'm going to go ahead and type in this equation. So 2x squared plus 2x plus 4. Like I said, this is a maximum point. We see that negative sign, so therefore it's going to go concave downward. My x-intercepts, again, are nice to count because the x-axis is going up by 1s. So I'm going to go ahead and just plot those x-intercepts. X equals -1, and x equals, what was that, 2. Nice, so x equals -1, x equals 2. Oh my goodness, my board is... my vertex point. I have to find that maximum point. So I'm going to go to Menu, Analyze Graph. This was a maximum, so I'm going to go down to number 3. I see that my vertex is right here, but I want to scroll just left of it, and then scroll right, and right away my calculator finds that highest point, which is 0.5 and 4.5. So that is my vertex point. 0.5, 4.5, which is going to be about right here. From that point, we know it's going to be concave downward. So from this point, right, my domain, I see that it continues on in the negative direction, right? So my x-axis is going to keep going on until negative infinity, and it's going to keep going right to positive infinity. Again, that's a common domain for parabolas, right? They go all the way left, all the way right. Pretty much the domain for all of these are going to be negative to positive infinity. My vertex point, which was my y value of 4.5, from that y value, my y-axis, I see my parabola is facing downward, going down to negative infinity. Alright. Once you finish that, you can look back obviously at any of these problems. Otherwise, you could go ahead and move on to activity 2A.3.